This question is related to simple pendulum as well as error analysis. So here there is a simple pendulum and its length and accuracy is given. So length is 20 centimeter and accuracy, let it be delta L, which is 2 mm. Can convert this into centimeter, 0.2 centimeter. And time period of 50 oscillation is given. So which means time period for one oscillation will be 40 by 50 seconds. Similarly, the accuracy is going to be 1 by 50 seconds. We need to find the accuracy of finding acceleration due to gravity. So, time period of simple pendulum can be written as t equal to 2 pi under root L by g. From this, I can write g equal to, we can square both the side and rearrange things. It will become 4 pi squared L by t square. Now we can start with relative error. So error in finding gravity, delta g by g, is going to be, like you might have learned this, if there is a parameter c, if this can be written in terms of a into b power n, then the relative error in finding c equal to delta a by a plus n into delta b by b. Even if this n is negative, we have to put positive only because errors are always additive. So in this case, we get 2 into delta t by t plus delta L by L. So 2 into delta t by t. So t is there, delta t is there. If I write, I will get 1 by 40. So that both the terms have 50 in the denominator, that will get cancelled. Plus delta L by L, 0.2 by 20. So L and delta L. We simplify this, we'll get 20 into 1.2. This is relative error. In the question, they are asking percentage error. So delta G by G percentage, which is equal to 1.2 into 100 by 20 percentage. So this will become 5. Yeah, we'll get 6%. So the percentage error in finding gravity, acceleration due to gravity, is 6.